friend recently asked me why it seems that the construction of infrastructure projects like roadways and highways it always seems to be running behind schedule, but that the design of that same project always seems to be completed on time. Well, the answer I gave was that in design you have deadlines. You have to meet those deadlines, so you evaluate a few alternatives, you select one, and then you move forward to meet the timeline set. But that brought up the question, what if the next alternative evaluated ended up being the best one? I'm Karen Weiss, Industry Marketing Manager for Civil Infrastructure here at Autodesk. And for the next 50 minutes, we're going to talk to you about how Building Information Modeling, or BIM for Infrastructure, and the 2013 portfolio will enhance customer workflows and give our customers the ability to evaluate that one more alternative at virtually any time during the design process, so you won't always be wondering, what if? BIM is delivering tangible business benefits for the infrastructure industry, from the government agencies that own and operate that infrastructure to engineering service providers and others that comprise the ecosystem of the owners. As you'll see today, here at Autodesk, we continue to deliver on the promise of BIM for infrastructure. Now, I know there's been a lot of skepticism in the industry regarding BIM and people questioning whether or not it's applicable on infrastructure projects, but I'm here to tell you that BIM is the real deal. Last November, McGraw-Hill conducted a BIM for infrastructure project survey, and the purpose of the project was to determine the overall incidence of BIM on infrastructure projects and to gather information on drivers for future use and current business value that's derived from BIM. The report showed that 46% of the respondents are currently using BIM on their infrastructure projects. But even more interesting is that the use is predicted to grow to 80% in the next 2 years. One reason why BIM is becoming so important in infrastructure is because the landscape of the industry is continually changing. So around the world, and including here in the US, we have a problem with aging infrastructure. I read recently that trains developed in 1903 could go 150 miles an hour, and that now we're manufacturing trains that could go 230 miles an hour. But trains in the US rarely get above 100 because the tracks and control systems are so old. People flocking to the city, new sustainability requirements, and climate change, these things are all driving BIM for infrastructure adoption as well. Now, I want to dig a little deeper into one of the industry trends that you see here, and that is the investment vehicle referred to as public-private partnerships, or I'm just going to refer to them as PPPs moving forward. PPPs have emerged as a way to bridge the funding gap and have been widely recognized as an innovative approach to funding that can help reduce project costs and accelerate project delivery. Now, BIM is proving to be vital on infrastructure projects that are funded this way. One of our customers, Stantec, has successfully used BIM on one of the largest roadway projects in Canada, the South Fraser Perimeter Road Project, which is also a PPP project. The South Fraser Perimeter Road project is a 1.2 billion Canadian dollar project. It's currently under construction. And PPP projects like this tend to have exacting schedules and cost commitments due to overlapping design and construction phases. So design teams are working at a really fast pace and are sometimes just a step ahead of the contractor. The team we talked to at Stantec said they would not have been able to keep that project on schedule without the use of BIM for infrastructure and Autodesk software. Other customers, such as Hatch Mott McDonald, which you're going to hear from here shortly, have started to take best practices they've established in buildings and use them for infrastructure projects. And really, we could spend all afternoon sharing examples of how BIM is starting to take hold in infrastructure, but they all come down to the same thing. I mean, the industry is gaining tangible business benefits from moving to BIM. Now, we're hearing loud and clear that the challenges our customers are facing need innovative solutions, and we believe Autodesk has the ability to help infrastructure customers meet the ever-changing environment in which the industry is operating. And the solution? The Autodesk Infrastructure Design Suite. So the excitement around suites has been growing since they were launched last year, and the big news for our infrastructure customers with our 2013 launch is the addition of AutoCAD Raster Design, Autodesk Infrastructure Modeler, and Autodesk Revit Structure to the Infrastructure Design Suite. Now, in a minute, Dana Probert, Technical Marketing Manager here at Autodesk, is going to take you through customer workflows that have been enhanced in this year's release, highlighting new functionality in the areas of interoperability, enhanced rail design, and the creation of more complete models. Before Dana does that, though, I want to mention a couple of key new features found in the Infrastructure Design Suite 2013 that she won't have time to cover, starting with key enhancements to Timeliner in Navisworks. Now, Navisworks has always contained a robust set of analysis and simulation tools, including the ability to perform construction sequencing or 4D simulation. The 2013 Timeliner enhancements now enable users to add the fifth dimension, or cost, to tasks in the schedule. So we can now include costs for materials, labor, equipment, even subcontractor or specialty trades. So I can tell you that this is something that folks have been asking for, and to give them the ability to communicate and understand costs at any time during project execution is going to be a big benefit for our customers. Now, Navisworks gives us the ability to create that complete coordinated model, but what about sharing and collaborating with extended team members? So as many of you know, Autodesk Vault Collaboration AEC is the data management and collaboration software for infrastructure professionals. And a couple years ago, we announced Civil 3D integration with Vault Collaboration AEC. So this integration enabled our customers to better manage and share Civil 3D model information. So not just drawings, but the actual models contained within the drawing. This year, collaboration is enhanced further with the Navisworks Vault Collaboration integration. So part of this enhancement includes preparing and sharing information with the field through mobile devices, which is becoming more and more common. Now, in addition to enhancements to Navisworks, there's several new and exciting updates to other software in the suite, including Map 3D. And one in particular that I want to mention is the introduction of linear referencing systems. Organizations who manage networks, whether electrical, water pipe, or transportation networks, often need to manage information relative to the network rather than at a specific point in space. So for example, sign inventory with location information is often stored this way. That way if the road changes, the signage goes along with the road. So you don't see a stop sign sitting in the middle of nowhere. So these types of assets always exist relative to that road network. So the addition of linear referencing systems gives our customers the ability to manage data the way that makes sense. So big news for Map 3D users. So the 2013 release, as you'll get a glimpse of here in a second, is really a great release. But of course, I'm one of those people who's always wanting more, and luckily Autodesk is always got something exciting on the horizon. And the one thing I want to share with you all is one of the technology previews currently available on Labs called Project Galileo Online. And this technology preview lets Autodesk Infrastructure Modeler customers publish infrastructure scale models to Autodesk 360, and then invite others to access those models, download, and then commit changes to them as well. Users can also publish models that can be viewed in web browsers or on mobile devices, specifically the Apple iPad 2. So stakeholders virtually anywhere can review infrastructure designs. So Project Galileo Online, taking BIM to the cloud, and something to keep your eyes on. So is BIM the key to creating efficient, safe, sustainable infrastructure? With BIM for infrastructure, our customers are finding that they can test and improve ideas long before they're built, exploring design ideas from initial concept through development and documentation. BIM means being able to visualize those projects with photorealistic renderings and walkthroughs, allowing you to experience your design as if it were already built. It means being able to simulate how it will perform in the real world, test, analyze, and improve the design. It means being able to evaluate that one more alternative. So, as BIM is generating steam in the industry, so are we here at Autodesk. And it's time to take a look at the 2013 release up close and personal. Dana Probert, famous for her blog BIM on the Rocks, among other things, will take you now through how the 2013 suite is positioned to take our customers to the next level.
Thanks, Karen. When Karen said that line about how, why is construction always behind schedule, but the design is always done on time, it made me remember a frustration that I faced as a new engineer. Back before BIM, we'd get to a point in the project where things were really coming together and we could see the design emerging. But we have this realization that we could maybe save a few feet of pipe here or a little bit of fill material here by rerouting the storm drain or adjusting the road grade. But wow, it really hits us that now we can see everything, now that we can see it all laid out before us, all these drawings, all this design work. We could have made a huge impact by placing the stormwater facility over here, or running the road through this area, or hugging the terrain a little bit differently. But that doesn't become clear until the project is really quite mature, back in the days before BIM. The project was good as it stands, but it really could have been great if we had experienced just one more alternative early in the process and really seen it come to life. We could go from simply meeting the standard to being truly exceptional. I want to spend some time digging into how our enhancements for 2013 will help our customers explore more alternatives. And as Karen mentioned, the three big things for this release are interoperability, an enhanced rail solution, and building more complete models. First, let's have a look at how interoperability workflows have been enhanced for the Infrastructure Design Suite 2013. Early in my career, I worked at Stantec in Edmonton, and I worked with a lot of planners, city planners, urban planners, land planners, transportation planners, and what a lot of them have in common is that they like to work on paper with pens and tracing paper. And they would have me print out this big base map, gather up some tracing paper and pens, and work through several alternatives. They take a lot of time to continually lay more layers on top of each other, and they'd bring these papers to me and I'd put them on the scanner. And it would really take me a lot of time to digitize those ideas. And I'd be limited to 2 dimensions. Once I finally got everything drafted into CAD, I was still very limited in what I could tell them, the story that I could tell them. So you might be surprised how little this workflow has changed in the past few years. I was speaking to a civil engineering customer recently, and she said, these guys still do a lot of paper sketches and really have no design tools that I know of. It's truly a rare few planners that will take the topography and other civil aspects into account. So there are 2 things that I took away from my experience working with planners. And the first was an appreciation for really nice pens. I still buy the brand that they introduced me to today. And the second was the realization that there had to be an easier way to tap into that creativity and digitally and experience their efforts in 3 dimensions. Raster design is new for the Infrastructure Design Suite this year. With its help, I can take a scan of those paper sketches and map it to my base map of geospatial information and assign real-world coordinates to the image. This is valuable for use with Map 3D and Civil 3D, but what if I could take the planner's ideas and turn them into a 3D model that everyone could understand? And what if I could do that in just a few minutes? With that image projected onto my model and infrastructure modeler, I can use simple yet powerful sketching tools to quickly lay out and model transportation design options without having to build in a lot of detail. I've only been working for a few minutes and I've already managed to breathe some life into that piece of paper, to see those planners' ideas in 3 dimensions. So Karen mentioned Stantec's work on the South Fraser Perimeter Road project out in Vancouver, here on the West Coast. And a few weeks ago, I was catching up on email around midnight, and I sent Dave DeYoung, who is one of the project engineers on the South Fraser Road project, I sent him a note asking if we could chat sometime about some of his thoughts. I wanted to pick his brain on how the project would have been different with a tool like Infrastructure Modeler. How much more could they have gone through in those preliminary stages? But, I'm over here on the East Coast, so I wasn't really expecting he'd call me back right away. But I'm always happy to hear from him, and it was only 9 o'clock for him, so we'll let it go. But we had a great conversation, and Dave said that if they had been able to explore more early alternatives, it really could have changed the entire mood of the project. They would have entered design with a far better understanding of the implications of each alternative and had more ideas about what to expect when they got to that detailed design phase. Which leads me to the question, how do we leverage concepts from Infrastructure Modeler in detailed design? Data can be moved from planning to design, from Infrastructure Modeler to Civil 3D, and then back again using a new data format called IMX. So new for this year for the Infrastructure Design Suite, a data exchange between Infrastructure Modeler and Civil 3D. Once I've chosen the alternative that I want to explore in more detail, so the alternative from Infrastructure Modeler that I'd like to explore in Civil 3D, I can pass the conceptual layout from Civil 3D using IMX. I continue to validate the design in 3 dimensions with tools like the Enhanced Drive command in Civil 3D. And once I've explored how I've built the road corridor and how my ditches and my overpass and all of the engineering details are coming together, I can do a more photorealistic visualization with 3ds Max Design, which is also part of the Infrastructure Design Suite. Once the detailed design is complete, I'm always rolling into the next level of detail. So for this sample highway interchange, the next step might be a planning to the entrance of the proposed airport or the site design of a nearby industrial park. The as-built condition of that last project becomes the existing condition of the next. And using IMX to share data between planning and design can help keep that model as accurate as possible. While all infrastructure projects benefit from a BIM process, the previous releases of Infrastructure Design Suite didn't contain any explicit tools for the railway designer. So let's have a look to see how that's been improved for 2013. On the surface, it may seem like railway design would be a lot like highway design, and in some ways they are, but really it's not just a road for trains. The geometric requirements are different. The operator cannot steer. Sometimes the operator is pulling a string of cars that can be a mile long. Steep grades and tight curves not only impact navigation and safety, but also cause wear and tear on the trains, which could lead to higher maintenance costs. All this has to be balanced together. The topography, the design, the horizontal design, the maintenance requirements, etc. Geometric constraints combined with those land uses along the rail corridor, local terrain, and the types of trains that will ultimately use that track determine how best to balance these requirements. Infrastructure Modeler includes intelligent rail elements that understand how to interact with the terrain. When this rail element here crossed the road, it knew how that's supposed to interact and created that rail crossing. Planners can now work through concepts to find that balance, giving both technical stakeholders and the public a chance to see what alternative routes might look like. I mentioned that rail must meet some very specific requirements, especially when it comes to horizontal curves. Customizable speed standards are built into Civil 3D, so I'm alerted that I need to adjust the design speed around this curve immediately, which means that I don't waste any time moving forward with a design that is potentially dangerous or won't meet standard. Another way that rail design adjusts when encountering curves is called cant. Cant is the equivalent of superelevation in roads. It keeps the train on the track and the people in their seats. The new Cant wizard for Civil 3D 2013 leads you through the process of applying Cant to your roadway alignment. Customizable options allow you to choose a pivot method, design criteria, and other parameters needed to help meet those local specifications. So with the geometry defined, I'm ready to consider the 3D model, or that corridor model for the rail. Both rail design and road design can take advantage of the new tools within Subassembly Composer to help create a more accurate model, regardless of the unique requirements. Subassembly Composer enables anyone, not just a computer programmer, to create their own custom subassemblies, whether needed to model something simple like this curb and gutter, or more complex, like this retaining wall that reads the terrain and reacts by getting taller or deeper depending on the requirements. Intelligent tunnels for things like highway, rail, or pedestrian tunnels, or even railways themselves. Once that corridor model is built, that 3D representation of my rail design, there are many reasons I'd want to do some validation or visualization throughout the project. As the designer, I care about things like slopes and widths and encroachments and conflicts, but the public might be more interested in understanding what the new rail line would look like behind their apartment complex, or even more importantly, will there be a Starbucks at the new commuter station? Most important right there. But so the 2013 Infrastructure Design Suite contains tools that help us. With my design complete, I like to pretend I'm their train conductor and ride the rails. The Drive command has been enhanced for Civil 3D 2013, making it easier for me to experience my design. I can use the command on more types of Civil 3D objects, and new tools have been added for easier navigation. Improvements such as Drive give you the chance to validate the design decisions at any stage of the process, giving you just one more chance to explore and experience that next alternative. Civil View is the connection between the detailed design and the photorealistic visualization in the Infrastructure Design Suite. This intelligent connection between Civil 3D and 3ds Max Design makes it easier for rail designers to tell that robust visual story that is easily understood by non-technical stakeholders. Here coming around the curve could be that person who wants to know what this new rail line looks like from behind their house or from their front porch. It really is an exciting time to be involved with rail projects. Between the increased world interest in developing and rehabilitating rail infrastructure and a new set of tools for benefiting from BIM and a BIM process, I'm looking forward to see what firms like Cory's, who you'll hear from in a little while, how they take advantage of this opportunity. There's more to infrastructure projects than simply just roads and rail. We've added new tools to make it easier for our customers to build that more complete model with Infrastructure Design Suite 2013. New tools have been added to Civil 3D 2013 with built-in intelligence for pressure network design. With access to a large catalog of common pressure network parts and their associated design standards, designers can be certain that they are building their model in a way that more accurately reflects what will actually be placed in the ground. The addition of Revit Structure to the Infrastructure Design Suite makes it easier to integrate civil structures to the design process. Working with terrain data from Civil 3D, bridges and tunnels are designed and analyzed and provide even more elements for better use in understanding how the project will really come together during construction, especially now that Navisworks has been enhanced for native Revit file support. Let's see how all this comes together in Navisworks. I see my Revit model, I see my pipes and my utilities and my pressure pipes all brought together into the Navisworks environment. When speaking with Roberta Oldenburg from Morton Construction last week, she told me that a model that better reflects the actual conditions is far more useful for understanding how the project will be constructed. Consider how much more realistic my construction planning can be when I am able to bring that water network together with my tunnel details and of course the rest of the road and surface and utility data for clash detection, construction scheduling, and more. Now, at Autodesk, we continue to deliver on the promise of BIM for infrastructure, giving you the tools to find that winning alternative. What if that next alternative you evaluated turned out to be the best one? It is now my pleasure to introduce Cory Dippold of Hatch Mott McDonald. His projects, his company have impressed me with how they've taken the idea of BIM to evaluate more alternatives. They've really taken it to the next level. So, Cory?
Hi, this is Cory Dippold, BIM champion for Hatch Mott McDonald, and we're going to spend a few minutes today talking about BIM for civil infrastructure. To get started, Hatch Mott McDonald is a partnership between Hatch Engineering out of Canada and Mott McDonald out of the UK. We're an engineering consulting firm that specializes in civil infrastructure and have grown to approximately 60 offices across the United States and Canada. We specialize in 13 different practice areas, which include highways, bridges, pipelines, water, wastewater, tunnels, and transit systems, and started using BIM approximately 5 years ago in selected practice areas, and are looking to expand the use over the coming years. So when we're looking at BIM for civil infrastructure, I think it's helpful to think of it in terms of an evolution of design capability. That evolution obviously carries with it some particular challenges. Specifically, it starts with the people. Many people think BIM is more of an architectural type tool, but we found it to be very useful in many of our infrastructure type projects. So winning the hearts and minds of the people that are involved in the work is a key first step in being successful in civil infrastructure type projects. Once you have the people on board, you're looking at evolving the culture of the industry, not just the designers, but the contractors and the owners as well, in terms of showing them the benefits that BIM can bring to a civil type project. Quite obviously, there's the technology aspect of it in using new and evolving technology and leveraging that to realize the benefits in the civil world the same way the architectural world has. And then obviously the workflow, where BIM continues to deliver benefits by streamlining the workflow. What we're finding is it often removes checks and balances out of the workflow that have been long-standing parts to ensure that the work is executed and the quality is maintained. And then obviously with all engineers, effectively managing that risk associated with these types of transitions. So to get things started, we're down in Los Angeles. This is the Crenshaw Light Rail project, where Hatch Mott McDonald was retained as the preliminary engineer of 9 miles of new light rail infrastructure. It starts in the south around LAX airport and proceeds northward. We applied BIM here in a very strategic manner to identify the most challenging parts of the project in terms of the coordination with the existing area. Obviously, this is a very urban setting that's going to have a lot of land acquisitions and working around existing infrastructure. It was also used to help support our clients' obligations in early negotiations with stakeholders to obtain the necessary approvals to make the project a reality. From here, we'll head up to the Port Mann Highway 1 project in Vancouver, British Columbia. This is one of our largest civil infrastructure projects, approximately 23 miles of highway widening and reconstruction at approximately $2.5 billion project cost. Includes the reconstruction of 13 existing interchanges and the addition of 2 new interchanges, 42 new bridges, 65 major retaining walls. Just a massive project in terms of the scale. Here, Civil 3D was used to model the entire corridor in 3 dimensions using various LiDAR and point cloud, as well as aerial pictometry and other existing condition types of 3D data acquisition. The interesting aspect is once all of the design was modeled in 3D, that 3-dimensional data was given to the contractor where they could use GPS automated equipment to help execute the work, to the tolerances of the model. Another interesting aspect here was migrating to the design review app so that a lot of this 3D data could be taken in the field in a very portable way to ensure that the existing work as well as the new work was executed in a manner consistent with the design. From Port Mann over to Ontario, this is the Windsor Essex Parkway, approximately $1.5 billion project cost, which will connect Highway 401 in Ontario to Interstate 75 in Michigan. Here, BIM was used very early on to do a lot of project visualization. The goal was really to minimize the environmental impact and enhance the community connectivity, or in other words, allow the owner to show all of the surrounding communities what the job would look like and really sell the job to these communities. From Ontario over to New Jersey, this is the Portal Bridge Pursuit. This was the construction management proposal that Hatch Mott McDonald was endeavoring to win. In this particular case, BIM was used to model all of the proposed work. In the upper right-hand corner, you can see a project animation we put together that really describes well the scope of work, which includes 2 new twin tide arch railway bridges, as well as the decommission of the existing Portal Bridge. Understanding that there's a lot of technical complexity to this project, we felt that the project animation just didn't communicate the technical aspects clearly enough. So using Navisworks Manage, we combined the schedule as well as the model data into a full project simulation, which shows in much more detail how the intended project would be executed right down to the various tasks level over time. Far more effective in communicating your technical intent than a project animation. Some of our more legacy type BIM work is around our wet infrastructure, our water work. This is one example, the Canoe Brook water treatment plant, where we're working with a partner and obviously a tremendous amount of complex coordination in terms of weaving a lot of process piping in a very tight area. When multiple firms are working on the same model at the same time, the coordination is key, and in this particular case, Navisworks along with the Revit platforms were used extensively in not only helping design the work, but helping coordinate a very complex network of piping in a very tight space. Some work of pictures of not only the renderings of how it would look, but field execution as well. One of our more interesting projects is this water interconnection facility for a major client. In this particular case, we were charged with connecting 2 pieces of critical infrastructure, both of which were in operation. BIM was used for a variety of reasons. Number one, not only to streamline the design effort, but really to manage risks on the project. Because of the sensitivity of both of these pieces of infrastructure, we needed to verify that all of this work could be completed, not only in a manner that would not damage the existing infrastructure, but that could be done without disrupting service for extended periods of time, as well as minimizing just the downtime for connections and tie-overs, things of that nature. Really interesting in terms of how we coordinated all of the existing work with the new work and really identified the critical aspects of the project to make sure that the design would be successful. So I think some of the key technology themes here at the high level is obviously the use of digital modeling for effective communication of design intent, or just project visualization. This is a good example where we combined aerial pictometry of the Crenshaw project with the design models, and it's often difficult to tell exactly what in this picture is existing and what is proposed, which obviously says that we did an adequate job of communicating our design intent if you can't distinguish between the two. We're seeing an increase in need for full context modeling of the project. On the Portal Bridge project, not only did we show all of the proposed infrastructure, but we also showed a lot of the infrastructure and a lot of the work as the project was being completed to verify that things like the channel that the ships would need to go through would be accessible, verifying that barges could be floated to the correct positions so that the cranes had adequate access to project site. And then obviously in BIM, the I is often the critical part of it, the information, and the ability to assemble and organize the model data in an effective means. In this particular case, we color-coded a lot of the existing utilities to not only identify what they are, but the level of confidence to where we knew and understood their relation with respect to each other. And then I think one of the promises of BIM is obviously to start to integrate a lot of the processes that design engineers go through. In this particular case, this is a dewatering facility that we did for a client. And in the upper right-hand corner is the model that was created. That model was fully connected with the analytical structural model. It was also used to drive all of the drawing production, and then custom schedules were created that not only had material takeoffs but integrated cost data, so that a change, that was originated in the model would be immediately reflected in the analytical model, on the drawings, and in the cost estimate. We took it one step further by integrating some of our project controls. In this case, all the shop drawings that came in after they were marked up were scanned and loaded up into our project delivery system, our document control system, and tied back to the model so that a user could click on an element and within 2 keystrokes be looking at the actual marked up shop drawing. And then obviously the visualization aspect. This is exactly what the Revit rendering looked like, and this is a photograph of the completed facility. So obviously, again, the ability to communicate with design intent effectively. So I think some of the key technology themes start with the vertical software, using the Autodesk vertical tools like Civil 3D and Autodesk Navisworks and Revit and Infrastructure Modeler and Autodesk 360. These provide the building blocks to really delivering today's complex civil infrastructure projects. The arrows in the diagram represent the project delivery from the standpoint that on any given project, the way that these arrows are connected dictate the success or the degree to which a project will be successful. And obviously, our ability to use products that are well integrated on top of each other to come up with a comprehensive design solution is what we're all striving to really achieve. With that, I appreciate your time, and we'll talk to you soon. Thank you.